We are covering earthwork calculations for the FE Civil exam, specifically focusing on mass diagrams and volume adjustments for shrinkage and swell. You will find a diagram and some basic earthwork formulas in the Civil Engineering section of the NCEES FE Reference Handbook. A mass diagram is a graphical tool used in roadway design that plots the cumulative net volume of earthwork against stationing. Think of it like a running total of cut and fill. An upward sloping curve on the diagram indicates a cut section where you are excavating more material than you are placing. A downward sloping curve signifies a fill section where you are placing more material than excavating. The peaks and valleys on this curve are critical. They represent points where the operation switches from cut to fill or vice versa. The vertical difference between any 2 points on the curve represents the net volume of cut or fill between those two stations. An important feature of the mass diagram is the balance point. Balance points are locations where the curve crosses the horizontal zero axis. Between two consecutive balance points, the total volume of cut is equal to the total volume of fill. This allows a contractor to plan earth-moving operations efficiently within these balance sections. Another key concept is free haul, which is the distance that excavated material can be moved without an additional cost beyond the excavation price. When material must be moved beyond this free haul distance, it is termed overhaul, and it incurs an extra cost, typically measured in station yards. Now, let's address the crucial topic of volume conversion, which is a frequent source of exam questions. Soil changes volume when it's disturbed. When you excavate soil, it becomes loose and its volume increases. This is called swell. A swell factor, say 25%, means that 100 cubic yards of soil in its natural or bank state will expand to 125 cubic yards in a loose state for hauling. Conversely, when you place that soil as fill and compact it, the volume decreases due to the removal of air voids. This is called shrinkage. A shrinkage factor of 15% means that 100 cubic yards of bank material will only produce 85 cubic yards of compacted fill. A common exam trap is to provide you with both swell and shrinkage factors and a required compacted fill volume. Then ask for the bank volume that needs to be excavated. You must use the shrinkage factor for this calculation. The formula is bank volume equals compacted fill volume divided by 1 minus the shrinkage factor. For example, if you need 1,000 cubic yards of compacted fill and the shrinkage is 20%, you would calculate 1,000 divided by 1 minus 0.20, which equals 1,250 cubic yards of bank material that must be excavated. The swell factor would only be used to determine the number of trucks needed for hauling that 1,250 cubic yards of bank material after it becomes loose. Here's a simple mnemonic to keep this straight. Swell is for scooping, shrinkage is for squeezing. You calculate swell when you scoop the material into a truck, and you account for shrinkage when you squeeze the material into a compacted fill. Always pay close attention to the state of the material mentioned in the problem, whether it's bank, loose, or compacted, and apply the correct factor. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.